Hi everyone, Cryorig have sent me two low-profile air cooler known as the Cryorig C5. On my left, this is full copper, and on my right, this is full black. And I believe the base is nickel plated. And both of these are making use of the technology known as the Vapor Chamber. Now, before I begin talking into details, thanks to Cryorig to send me these two units and to share with everyone. Alright, starting off with the unboxing. Now, when you receive this package, it's sealed. Okay, you can just cut off, but I have a better way. As you can see, both are sealed. I can remove the package this way. Okay, now both units have the same accessories and such, it's just that the build are different. So let me just show you. Nice package of accessory which I will go through. Then inside are the unit, and it's been sealed properly. And one thing good is that they have fully protect the package before they box into the box. Now let me just take this off. So this is the black version. These are low profile, and this is the full copper unit. I guess the difference is the material. Wow, this is nice. I like this more than the black version. Anyway, we shall test how the thermal is like. Now, as mentioned to you, the difference is on the color and the coating. Else, for this, right, you have a white fan, the full copper heatsink, and it's very nice design. And this is of the black version. You have the black fan and the black heatsink, and the base looks like this, and this is nickel plated. Now the vapor chamber is sticking out, as you can see over here. Same goes to the full copper. Okay, I'll go into details later with this. As mentioned to you, both packages are of the same. And what do you have? You have the instruction manual to install the Intel and the AMD. By the way, for AMD it support AM4 and AM5, and for Intel it support 115X, 1200, 1700, and the latest socket, which is the 1851 socket. A notification on how you should be mounting the mounting board to the IHS or your processor. You have the Intel backplate, which has very nice logo, nice, all listed over here. All these are the mounting board and spacer. This is for Intel, and this is for AMD, and a tube of thermal paste. I believe this is actually 2 grams. I like the way how they think, and it's very considerate. I'm hoping that all the rest of the brands, be it air cooler or liquid cooler, right, should have some packaging just like what Cryorig have done. Now, why do I say this? If you are to use all these accessories and to use the thermal paste, and there are some leftover on the thermal paste, right, you can put it back to this package. And the rest of the accessories, right, you don't have to take out, you just put it there. And those that you do not need, right, you can place it back. And this is a one whole package which is sealed. I can throw it. See, it doesn't go loose, so you won't lose any parts. A very mindful and considerate way of packaging the accessories. Well done. Now, on the main unit itself, as I mentioned, on this is full black with nickel plated, and this is full copper. I believe this will do better heat dissipation, which we will try later. Now, on to the design of it. How this thing works is, it draws cool air from the top and to dissipate out from the side, which is through the fin stack. This is how it cools. And with this say, right, there are additional air that's coming out from the fins will cool off the VRM heatsink or your M.2. As this is mounted this way, unless for Intel, which you can mount it this way, it will cool the back rear VRM, and at the front, which is your RAMs. Nicely done. And the design of it, okay, with this ARGB diffusion on the fan, right, it will go through here too, giving you a very nice, I would say, silhouette kind of ARGB effect. Nicely done. Now, at the base, as mentioned to you on the black, this is nickel plated and this is copper plated, and this is where the wiper chamber is. When you look at it, right, there might be circular lines and such. Don't be fooled by it, okay? In fact, when I go through, right, this is smooth, it's flat. It's just the way that they design it, I guess, or to see the whole mechanism. So this thing is fully flat. Same goes to this. Now, as for the dimension of the fans, or should I say the top part, okay, this whole block here is measuring from the top to the bottom, from the left to the right. This is at 97mm. And for the fan measurements, right, top to the bottom, left to the right, this is at 96.8mm. And as for the height, the overall height is at 54.9mm. If you want to just measure the fans itself, right, or the top cover, right, this is at 31.5mm. Now, this is a 7-blader, okay, and as you can see, right, it's quite steep, so it will scoop tons of air and it doesn't wobble. Now, there are no specification of what bearing this is. I wouldn't know what that is, so sorry about this. And for the airflow of this fan, right, is at 51.51 CFM with a static pressure of 5.35mm H2O. And as for the RPM of this fans, ranging from 500 minimum all the way to 3200 plus minus 100 RPM. That's right, pretty cool, eh? Now, to remove all this top off from the heatsink, because you need to remove this in order to fit the heatsink to your IHS. All is needed, right? Place this not with the logo, but with the fin stack to the bottom. Okay, grab over here, push it, and you'll be out. It's quite simple. And to clip it back, it's just to clip. Okay, now forgot to mention that the ARGB and the fan RPM, right, is controlled by these two cables, which you need to plug to your motherboard. The 4-pin PWM connector, which is to control the rotation of the fan, the RPM, and the 3-pin 5V ARGB connector. Alright, now back to the fin stack. Okay, probably I'll just remove this too. There will be total of 61 fins as I calculated, be it the black unit or the full copper. And as mentioned to you, right, wow, this is very gorgeous. Let you have a look. Okay, I know I have fingerprints on there, but this is how it looks like. Probably I should clean it. Okay. Yep, much better. See, I like how they designed the copper heatsink. Fascinating. For Intel, you will need to have the backplate, the 4 spacer, which is in blue, and the mounting board. First thing you do, of course, mount your processor, put it in place, make sure that it doesn't move about, followed by removing the fan off from the heatsink. As this heatsink, right, you will need to use these 4 holes for your mounting board. Okay, you will note that there are some cutting over here. These are for AMD, but we are using the Intel. Okay, you can put this one side once you have detached the fan off from the cold plate, or should I say the heatsink. Now for this, right, I wouldn't advise you to place one side this way. Have the cold plate above so that you don't scratch this on your surface. Next thing to do, prepare the back plate. Now as for back plate, right, if you take a look closer, you have this 11.5x, 1700 and 1366. it happened that this is a 17 socket, so I will need to push this to the 1700. So it's actually in the middle. Do the same to the 4 sides. Okay, once you've done this, turn your motherboard to the back. You have this 4 holes over here. Okay, let me just zoom in. You have all these 4 holes over here. On the back plate, right, this protruding up should be facing downwards. So you can either place it this way or place it that way. Now, a lot of you, I know you'll be struggling to, align the holes itself. You don't have to. Just place one finger at the top where the thread is. Place it on the hole. Okay, this will glide in. See, this is your anchor point. Done. Now, something for Cryorig, I hope that you guys will place some double-sided tape. So when I mount the back plate, right, it will be in place, hold in place. So when I flip it, right, this will not drop. Assuming right now I have mounted in and I flip over, right, if I don't support this, see what happens. Whole thing will drop. Alright, back to where I was. So again, one finger on one thread, align to the hole, slide in. It's that easy. Support it, turn over. Now when you're turning over, right, you might be saying, hey, I'm going to leave the board on the mat, then this will just drop. True enough. That's why you use this, the mounting bolt, to anchor the point. So right now I just anchor one point and to the other. Alright, once I've done this, right, take a look what happened. I can drop the back plate, no problem, see? Okay, as there are 2 anchor points securing the back plate. So right now I'm just glide gently, so you align accordingly and this will be in place. So you can take out these 2 mounting bolt. Next thing to do, okay, place the 4 spacer. Now for the spacer, it doesn't matter the direction, whether you place it this way or you place it that way, because this whole thing, right, is the same. So just place it to the 4 thread holes, and especially the corner here is pretty tight, so make sure you place it nicely. Now next thing you need to do, apply alcohol. Use this wipe, can be coffee filter or whatever you choose, just to wipe it clean. Once that's done, right, apply thermal paste, which is provided. Once that's done, you can clean the cold plate with alcohol. Okay, as you can see, right, I did clean it. See? So a lot of you tell me that you don't have to clean it. It's very clean. Some with the tape, right, it's very clean. No, take a look. Alright, so make sure you clean it. I re-clean it. So to mount this, right, hold on it. Now mounting of this, right, also have a knowledge on this. As you know that the rear VRM, the 12 phase, okay, assuming this is 12 phase plus 2 plus 1, okay, the 12 phase is in fact the VRM that provide current or voltage to your processor. So you need more cooling on the VRM at the rear. So you'll be much wiser to have the fin stack facing that way. So when the air go through, right, it will just cool the rear too. Okay, assisting the cooling. And as for the top, right, it's only phase 2 plus 1. The 2, which is control the current going to your RAMs. You might say that, hey, the RAMs are important too. Don't worry. The front part will be cooling your RAMs. So you don't have to worry a single thing. So with this say, right, to place this, right, assuming you have the thermal paste, okay. Now, the processor right now I'm using, right, is damaged, so I can't illustrate to you the thermal result on the, on the 13700K. So assuming this is the thermal paste, okay, why am I doing this is because I want to protect the cold plate from scratching, so that I can mount on the AMD to show you the results and such. So assuming this is actually the thermal paste, once you have applied, right, it's time for you to mount the cold plate. And when you mount, right, don't just press it in straight. I'll advise to anchor one point again. Okay, I always do this, as you can see. So check this to the hole. Same when you're threading the rest to the holes. So I'll go by slow. I'll do 1 point first. Okay, once this is in place, I will just do a anti-clockwise till I hear a click. Okay, turn 1 round. Okay, once this is done, right, see you have the anchor point. So right now you can just press down, wiggle a bit, so that your spread, you know, your thermal paste spread will spread nicely. Still holding on to this, right, mount the rest. Do it diagonally. Okay, where is my screwdriver? Over here. I will do anti-clockwise till I hear a click. Okay, screw it in. 1 turn. Do the same to the rest. Now as you can see, right, when I do, right, I switch hands so that I'm still pressing onto the cold plate, as I don't want bubble in between. So just to make sure that even pressure is pressed to the processor, between the cold plate and the processor. So again, okay, click, 1 turn. Do the same to the last spot. Okay, I can't see this spot, so I have to move. See, I'm still holding it. Ah, no good, no good. Okay, so I place it in. See, I hear a click, 1 turn. Then once you hear this, right, you can start screwing in. Now I like to do it alternately with, you know, 1 turn point, 1 turn point, so that I know that there will be even pressure to the cold plate. Okay, I'm not going to screw it all the way, just showing you. Now when you screw this, right, alternately, right, you have a equal balance to it. Now at all times when you're doing the screwing, right, make sure that your hands is actually on the top, so that there won't be bubbling in between the thermal paste of your cold plate and the IHS or the processor. So when you screw this, right, until you feel that the screws can't go in anymore, don't tighten. Okay, don't over tighten. That will be done. You will be having an equal pressure. Assuming this is done, the final step is to clip this back in place. As you can see, the fin stack is over here, right? The clip is over here. Okay, so just clip it. You can choose to clip it this way, which I feel that this is too long, so I'll just clip it this way. Alright, this is done. Next thing to do, plug your most important connection point, which is the fan, to run the RPM, the 4-pin PWM connector. Connect to the CPU fan, which is here. Okay, don't connect to the CPU op. This is CPU op, by the way. Okay, let me just push this up. Okay, let me just zoom in. Now for the fan itself, right, okay, don't think you guys can see. Let me just, okay, hope this is better. Now for the fan itself, right, on the motherboard, you will notice that there will be labeling as CPU_1 or CPU op. I would advise you to plug on the CPU_fan. Okay, this is the master control. So as mentioned, this is the 4-pin connector. Okay, connect to the CPU fan 1. And this is done. As for the last step is to plug the 3-pin 5V ARGB connector, which controls the ARGB on the fan, to the ARGB header on your motherboard. So you can choose either one. Anyway, to control the ARGB is to make use of the motherboard utility. So once you plug this in, right, done. For AMD, basically you will need the red spacer, the mounting board, 4 of them. Same goes to the spacer, total of 4. Then first thing you need to do as mentioned, remove off the fan off from the block, as you will need, you need clearance to mount the boat. Now when you place it one side, right, please make sure that the cold plate is facing upwards. Do not face it downwards, because you wouldn't want to scratch the cold plate. Once you have done this, right, unscrew these 4 screws, take out the original bracket. Next thing, the 4 red spacer. Now it doesn't matter which direction, it's all the same, so you can just plug it to the 4 thread holes. Once this is done, right, apply alcohol on your processor, wipe it clean with a towel or coffee filter, then apply thermal paste, which is provided. Now you might be curious, how come I already have a thermal paste on it? I have already applied this on it, and you've been wondering how come it's so perfect square. Well, not really perfect square, as you can see over here. So basically what I've used, right, is not using those protective sheen or such. Basically what I'm using, scotch tape and kitchen wrap for food. So these are 2 things that allow me to do my paste with my fingers. If you want to know more how I do it, you can click on my top right hand corner. It will take you to that content and it will show you how I did it. Now the next thing is, on the cold plate itself, I would advise to spray alcohol on it. Let it sit for a while so that all the residue will be taken off. As I was illustrating on the Intel, right, I noticed that when I wipe, see, all the yellow substance or orange substance coming out. So after sitting, right, just clean it. Make sure it's nice and dry. Okay, let's see. Now based on the fact why you need to clean this, because this is full copper, and during the shipment or such, right, there might be oxidation or such, so you might just stick on the surface, so that is not very good. Okay, done. Now next thing is holding on to the cold plate. Alright, do not press it down first. Anchor this 2 point. Okay, which I will do it on anti-clockwise till I hear a click. Okay, let me just put this down. Once I hear a click, 1 turn. Second one, once I hear a click, 1 turn. That's it. Now what you intend to do is, on the cold plate itself, if you notice, right, there are 4 nuts over here. So you're supposed to bolt this, okay, this way, to hold the cold plate and press the pressure to your processor. So with these 2 anchor, right, I will just simply plug it in underneath. Okay, once it's done, I'm still holding on to the cold plate. Do not press it down. I will fill up this too. See, I'm holding it so that this cold plate will not sit in first. Okay, it might look silly, but it's better this way. So having to, okay, once you hear the click, turn, 1 turn. Same goes to the other. Now I'm still holding up. I'm not pressing the cold plate down. I hear a click. One turn. Once it's done, I see I'm actually holding it. Press it down, wiggle. Reason for this, right? Based on the fact you don't want the cold plate to touch the thermal paste when you're mounting it. So once you have the 4 anchor point down, right, you can press it down, wiggle it a bit so that the pressure, right, will just spread your thermal paste evenly on the between the cold plate and the IHS, which is the processor. Right now, still holding on to it. I will just do the tightening. Now for my style, I will just do one turn, go over here, one turn, over here, one turn, and over here one turn. So do it continuously. You might choose to put 2-3 turns, 2-3 turns, 2-3 turns, it's up to you. But my style is I always like to go one turn, because I want an even pressure to, you know, the cold plate to sit on the processor. So that will give me a 100% good result, or should I say more than 98% good results. See, I'm still holding on to the cold plate until when you find that the screw is tightened till it stops, then you can stop. Okay, this is done. So you can't turn the screws any longer, or should I say any further. So this tells me that the cold plate is seated nicely. Next thing to do is to put this on. Now the fins is catching over here and catching over here, so what you need to do is to place this nicely. Look at how it's being catched. It's this way and this way, so it's catching here and here. So you need to place, let's see, I guess I'll place it this way, it's the best method. Okay, anchor one point, that's it, done. Next thing to do, plug the 4-pin PWM connector and the 3-pin ARGB connector. Starting off with the 4-pin ARGB connector. Over here I know it's CPU_fan. Make sure you plug it to here. Okay, this is pump and this is system. I will not plug on pump or the system fan. System fan is meant for chassis on MSI board. So CPU fan 1, this is done. Next, the ARGB 3-pin 5V connector to the header, which is meant for your addressable RGB on your motherboard. And done. Going to do a noise test. As you can see, my microphone is away from the cooler, about half a feet. Do a mic test. Now this is at idle, and as you can see on my screen, right, the RPM is running at 1420 RPM. And if I were to load this, right, this will go up. So take note on this. The full speed will be 3200. Now this is at load. This is at idle, and the RPM is ramping down. If you have not noticed, right, earlier on the RPM went up all the way to 3300, which is matching the specs. Right now I'm just going to push it to ramp up, but before I do so, this is at idle, and this is at load. Now as you can see, when it's at idle at 1400 RPM, I can't hear a single thing of where I'm sitting. I'm actually away about half a meter, and if this were to place in the case, right, at idle definitely you can't hear anything, and at load, yes, you do hear a bit of noise, but this is half a feet away, that's why you can hear. But if this is 1 meter away and inside the case, you won't be hearing anything. Now I'm just going to conduct the thermal of this air cooler. Now for the noise test B, whether I'm using the black version or the full copper, right, they sound the same. Now as you can see that my room temperature right now is 30.4 degrees Celsius. It's hovering around 30 to 31 degrees Celsius. So I'll be conducting the thermal in this room temperature. For the test, I'll be testing on both air cooler, be it the black or the copper, that's for sure. And at my room temperature, which you have witnessed, is 30 degrees Celsius to 31 degrees Celsius. Now, these are the specs that I will test on both air cooler. You can pause this and have a look. And you might be asking, hey Kill, both air cooler are rated at TDP 180. Why didn't you use the 9950X and the 9950X 3D? Well, I have done the test before I changed out the processor. The reason that why am I not showing you the 9950X or the 9950X 3D, based on the fact that there are tons of thermal throttle, okay, and the base speed of both processor is not able to catch up to 4.3 gig. In fact, it's hovering around 3.8, which is not a very good sign, and most of the time is at a temperature of 96, 97 and such. So I have to tone down. That's the reason why I use this 9700X. And with this say, right, I've locked down quite a number of things with this processor, whereby the default voltage 65 watt, I remain that throughout the whole run on this test itself, okay, for all the 4 tests that I'm showing you. Now starting off with the first run, I'll be doing the standard stuff like B-core offset, which is minus 0.05 volt, and the SOC voltage I fix it to 1.15 volt, and only with expo on. This is without curve optimization or curve shaper. So as I run, if you to have a look, okay, for the first few minutes it's okay, but I noticed that the temperature on the CPU is catching up real fast. So let me just drag you to the last 3 minutes, okay, which is around here. Okay, yep. Now before I let it run, I've done up a very nice chart. So I would be taking down the readings. So this test here, right, in fact it's the first one. This is without the curve optimizer and curve shaper, but of course with the rest like B-core offset and such. So I'll take down the readings, and I mentioned to you the power drawn, right, the CPU power, right, is locked to 65 watt, okay, so that there won't be any thermal throttle. So just let this run. While running, you can actually take a look at the stats, you know, how the V-core is reacting, and the graph here, and the max boost and the base clock. So I'm just going to write all this down here. Temperature is 76 degrees Celsius. Then Mambo is at 49. MOSFET, which is the VRM, is 47. Now probably you might say that, where do I get this reading? I get it from here, okay, 38 degrees Celsius, 38.5 and 43 degrees Celsius. Okay, let me just add one column over here. Sorry, not here. I would say is after here. Yep. Chipset. I would just take down the chipset figures too. As you know that this, right, CPU power, I need not have to show you. It's fixed 65 watt. So just leave it this way so that you can see the whole thing. In the meantime, I'll show you that, you see, this is the CPU power drawn, 65 watt. Alright, gonna write down the chipset figures, which is at 51 degrees Celsius. Oops. Okay, invert the CPU. Last 2 minutes, 3 minutes. Okay, let me go through again. Last 2 minutes. Okay, I should take 77 degrees Celsius. Alright. Now, base clock and boost clock. 4.48. This is the base. And the boost is at 5.545. Okay, spread this out a bit. Easier to read. Let me just reconfirm everything. Okay. I'll take it at 4.9. Alright, since it's actually running that. Okay. So sorry. I'll just take it average, alright? This is around there. So long you know it's actually 4.4 gig for the base and the max is 5.5. Alright, here we go. Now after this run, I will be polling to see the results. Okay, it's around here. Okay, this is the result. Now I feel that by showing you what I'm doing is better than, you know, just to play music and then you look at it while at fast motion, so that you guys, I'm not too sure if you can catch, because it's like, you know, this like that. So that's the reason why I prefer to talk through the results and such. Now second run, this is where I kick the curve optimizer and the curve shaper, where you can see the medium frequency, all three temperature is at -15. The high frequency, all three temperature again at -10. Not again, I should say that the tree temperature I've set it lower, which is -10, and the max frequency, the tree temperature is -0.5. Now, so as I run, the first thing that I will show you is the CPU power. See, I will lock it 65 watt because I don't want any throttle. And looking at the temperature, wow, okay, it's pretty okay. Then looking at the rest and the graph. Now the graph is rather, throughout all the runs, right, be it I'm testing the black or the white, you will see jaggers. It's not really that consistent. I guess this is actually the limit of the both air coolers. Alright, let me just pull you to the last 3 minutes and I take down the readings. It's around here, I guess. Yep. So at the last 3 minute, temperature is horrible. Okay, not say horrible, I mean it's still okay, sustainable, but do remember this is running on 65 watt. Okay, wow, 79. Should I take 77 or 78? Okay, consistency 77. I guess that is just a slight burst, that's why it went 78 or 79. Alright, mumbo temperature, taking from here, 50 degrees Celsius. Then the then the chipset, no, MOSFET, sorry, the mumbo, I mean the VRAM, 47.5, and this is at 51 degrees Celsius. The RAM's 39.8, and the second DDR5, the RAM's 40.2, and the last one, which is the M.2, 42. And the base clock, wow, okay, 4.7, 4.6, 4.8. Okay, let me see how much it, okay, I'll set it to 4.75 average. Now for the boost clock, I will take from here 5.550. Okay, now for the results, I believe this will be much more better because the base clock have exceeded, inclusive of the okay, not really on the boost clock but on the base clock. Alright, I will just go to the result. Okay, this is the result. So it's at 20K 84. Alright, next I'll be testing on the copper heatsink, I mean the air cooler. Again, these are base specs, just with the B-core offset, the SoC voltage fixed, and expo on. So as I run, right, okay, probably I run. See, this is slightly lower, which is good. Now, this is just the beginning around the 8 minute mark. So I'm just going to pull you to the last 3 minutes, as you can see over here. Okay, here. That's right. I'm just going to run this. Okay, while it's running, let me take down the readings. So much cooler, 75. Now, do note that I've not gone through this recording. In fact, most of this tree, right, I just recorded 3 times and I took the best out of the 3. So, having to test 2 coolers with 4 different sets of data, each of them I run 3 times and I pick up the best based on the CPU temperature. I've not seen the rest yet, so do take note on this. Okay, what I'm trying to say is that I pick up among the 3, right, the best thermal on the CPU. I'll just put it here. Okay, so this is just like having the experience together with you while sorting things out. Alright, gonna write down all the temperature. 56.5 for the mumbo, the VRM 40 degrees Celsius. Wow, okay, this is chipset is 48.3. Yep. Okay, missed this out. Okay, now for the RAMs, 36.2, and this is at 36. For the M.2, 39 degrees Celsius. Wow, big difference. Alright, boost clock 4.4. Oops. 4.4. Let's see. I guess it's around 4.30. Oh, 4.8. Okay, it's really hard to catch. I'll just put 4.461. Alright, done. Then the boost clock 5.530. And the scores, let's see the scores. Okay, the scores is this. So it's 19383. Alright, last set, which is done with the curve optimizer and the curve shaper on the copper air cooler. And this is when it runs for the first few minutes. On the 9th minute, I should say, going to the 8th minute, but somehow it's doing pretty good. Okay, let me just draw to the last 3 minutes before I write down the readings. Okay, here we go. Last 3 minutes. Whoa, 76 degrees Celsius. This is nice. Then over here, Mambo is 46.5. MOSFET 40 degrees Celsius. The chipset 48.3. Okay, in case you guys are curious, how do I do the degree Celsius? Just hold on the Alt key, press on 0176, let go. Okay, you get this degree degree sign. So that's how I do it. So I repeat, it's actually alternate plus 0176. Okay, and let go. Just hold on the what you need to do is just to hold on the Alt key. Okay, hold on Alt key, then press 0176 and let go on the Alt key. and you will get this sign over here, which I'm going to do it. See? All right. Okay, not going to waste time. For the DIMM, let's see. I mean the RAMs. The first is 35.8 degrees Celsius. Next will be 36.5 degrees Celsius. And for the M.2 is 40 degrees Celsius. And for the max boost, wow, impressive. Okay, I'll take it as 4.8. 57. I need this to, okay. I think I should lower down. I just put 5.82. No, 827. 826. Alright. Base clock. I mean the boost clock 5.550. And the result is $20K 754. Okay, there you have it. All the tests done. Now look at the overall results over here. As I mentioned to you, right, the copper will definitely run better than the black. Though I've kept the 9700X at 65 watt, but it still be able to sustain the 8 cores. As you know that the 9700X is also a hot chip if you do not have proper cooling, especially when you exceed to 105 watt. But this I've locked to 65 watt, I mentioned to you. So when you look at the stats, right, for the black and copper, right, I would prefer to go with the copper. Reason being, right, take a look at the thermal. If I were to take the default over here, okay, and place it over here, and the default on the copper, without any curve optimization, just the VCall offset and the SoC fix with expo profile on, you can see a significant change. Okay, and the scores are better. So this proven that the copper air cooler, right, is, I would say that it's much worth getting. But the thing is that for the whole copper with the white fans, right, the aesthetic might not be as good looking as the black. Okay, this is my honest opinion. Okay, now coming to setting the curve optimizer and such, if you were to take this and to compare again the black and the white, or should I say the copper, take a look. See, it's so much, it's so much lower. Now maybe the CPU temperature is not that much, it's about 1 degree Celsius difference. Okay, cause I believe this is pulling the clock speed, as I noticed that some of this thermals are pretty close. Okay, all this, but overall I will still choose this copper over the black, based on the fact that yes, you look at the result, it's more than that, and you look at the base clock, it's more than that. And if I were to compare this, okay, now I'm just gonna delete this. If I'm just gonna compare this after tweaking and such, right, with the original, right, see, I would definitely choose the copper base. So there you have it, the results are out, and it's able to sustain a default TDP, I should say, or the wattage of 65 watt of a 9700X. My take about the Cryorig C5 and the C5 CU, they're good, they're bad. Starting off with a good point. First impression when I unpack it, my goodness, it feels so premium. It's so well packed, and it's all very well protected on the cold plate and on the fan stroke, and they use this to wrap it round. So when this box is delivered and they throw, right, the exhaustion impact will be on this form itself, not hurting the components. Very well thought by Cryorig. And this seal here, which kept the unit inside, there is a silicone gel package which absorb all the moisture that might damage, the unit. So that is a good thought too. I'm not saying that the silicone gel will damage, it's like absorbing all the moisture from the component. This is a good point. Now, another thing is that the diffusion of the ARGB, yes, probably you might say that it's standard, etc, etc. Now, during my B-roll, I have typed out a word, wait for the moment. And the next moment when it slows down, I say, did you guys catch the difference? I'm not too sure if you guys catch the difference. Now, I am very excited to play with the copper first before the nickel plate. So what I did was, when I plug this in, when I fire up the system, the first thing is not the ARGB that attracts me. What attracts me is the underglow ARGB that is reflecting on the copper fin stack, which hits on my motherboard. My goodness, that was so, I would say, a form of art, leaving some ARGB on the silhouette of your motherboard, and that is detailing. In fact, that's something which I like. So with this area, I was saying that, oh my goodness, this white kind of like, doesn't pop, because my motherboard is popping because due to the undergrowth. So I changed this out to this. Take a look. This pops up straight away instead of the white. Reason being, right, all this logo over here, it does shows that this is Cryorig. This is what I feel. Plus the undergrowth, fantastic. It blends in so well. So I hope that Cryorig can do us a favor, probably come out with a black shroud, black fan shroud on the copper. Instead of just having it white, which I don't really think it stands out that well. Well, this is my personal taste. Now, besides this, right, take a look at the cutting on the block. Nicely done. And I thought these are CNC cutting whereby it's not flat, but when I clean it, I realized that it's actually flat. Similar to this area over here, it's all flat. It's just that the imprint of the pattern, right, they have done it and done the flatness, or should I say foul or polish to flatness. Nice. See? Alright. Now, besides this, right, the cover, the package, as I mentioned, is well done. Another thing which I really enjoy most, this. I hope that all brands can actually follow Cryorig's example, having such package. You know why? Okay, this is not meant to be rude, but just an illustration. Okay, one of it is on my floor. Let me go get it. Hang on. This is dropped on the floor, and yet it is still in, one piece. So assuming you have used the AMD set and leaving the Intel, right, you can just leave it in the package. As and when you want it, right, you can just take it out, because this will not go missing. As I show you, I throw. See, it's all intact. Another thing I like to emphasize is that when I remove off from the test, when I change the copper or to the nickel plated cold plate, right, and to do another run, now I find out that the even pressure, if you've done a perfect spread method, right, the spread is fantastically balanced. Okay, let me just fast forward and probably show you the picture. See, this is what I get, a very good balanced pressure where the thermal paste, right, it covers up the whole area, and this will definitely yield very good results. And based on the fact that the cold plate on this, both air coolers, right, be it the copper or the nickel plated, is very flat. Alright, with this said, there are things that I do not like about the unit itself. First of all, when I look at the TDP itself, now I did a mistake. on the copper unit, right, this is rated as 180 watt TDP. So I assume that the nickel plate is also 180, but I didn't realize when I read the specs on the box. Now this is the copper unit. This is correct, which is 180 TDP. And also this, which is the black version, this is the black version, is at 165 watt. So there is a difference on these two. And the weight, as I mentioned, did I mention? Okay. The weight of the copper is much heavier compared to the nickel plated. Okay, this shows how much weight this is to cool down the processor. But sad to say that I was actually anticipating that it can run a high-end processor, but it failed. It can't go past the base clock of a 9950X or a 9950X3D. Now, I won't fault on the cooler solution over here. I only can fault that the place that I'm at, which is a hot and humid country, and my room is always hovering around 30 to 31 degrees Celsius. I just can't make use of the high-end processor. So if you guys want this low-profile cooler, which is meant for SFX or even MATX, go for mid-tier processor like the 9600X or the 9700X. And mind you, when you run that, make sure you run at 65 watt and not more than that. Anyway, I've already shown you on a 9700, oh my goodness, 9700X, you perform, even I'm running on 65 watt. As you can see, the boost clock with the curve optimizer, it shoots all the way up to 4.8 gigahertz, which on base spec from AMD, right, it's 3.7 base clock, which is like, you know, far away, and it did meet the boost clock, which is 5.5 gig. See, why not? It's like running lower current, but yet can perform, right? So it's a win-win situation. So I wouldn't say that this cooler are bad. It's just happened that in my country, I mean, in the area that I'm at, or should I say my room, is always hot. So you gotta understand that my surrounding, right, even though it's actually blowing the intake of air and such, right, those are warm air. So this will affect the nickel plated, and this will naturally be warm before absorbing the heat from the processor. So this is actually what happened. Now, coming to the bad points of this, one thing is that I find that the cables on this fan strap, right, is rather long. I mean, why do you have to actually have such long cable? I can understand on the ARGB, probably you want to, you know, link it to other ARGB devices, it can be long. But for the fan, PWM fan header, right, imagine that your plug, okay, this is, okay, don't mind me, just illustration. I wouldn't want to scratch the cold plate. So imagine that I have plugged this in, okay, on the motherboard. The header is around here and here, and you have such a long cable. You have shortened this for better cable management and such. So this is actually one of the bad things that I feel is not right. Now, another thing is that, okay, I'll be taking this out. Something which I really don't understand, that why they have designed the backplate this way. They should have done with the thread, you know, sticking out. So when you mount it, right, and having the bolt, okay, take for example, the 4 bolts, mount them directly. See, on this for Intel, there is. Okay, because this hole here, right, is strong enough to hold the bolt. Probably I would put a washer at the other end so that this is actually on the cold plate. So I can just mount it direct and to screw it. I don't have to, like, you know, control the cold plate and to control the screws, which is rather troublesome. Same goes to the AMD. Okay, AMD is this. I would say that, you know, I mean, this is not a hindrance. You can just widen this. Okay, means to say there's a piece over here, and having the hose something like that, so we can hold on. I mean, the board itself, right? You can hold on to the cold plate itself. Again, I don't have to fiddle with the screws. I just place the spacer and to mount it straight and to screw. See, it's direct. Imagine this is already there. This will be much more easier. So something that, you know, Cryorig should have thought of. Now, other than that, I have nothing much about this unit. Pretty well done. And I would like to thank Cryorig to have provided, so sorry, okay, in the mess, provided this unit for me to share with everyone. And I forgot one thing, that is to thank AMD Singapore to have provided a loan unit, which is the 9700X. Initially, I was testing on a 9950X and a 9950X 3D, but I do not have a mid-tier processor, so they came to my aid. Thank you very much, AMD Singapore, and hope you guys have actually enjoyed what I shared with you. For those of you actually new to my channel, welcome to my channel. If you like my content, do remember to subscribe and to click on the notification bell button. And do me a favor, please hit on the like button if you like this content. With this said, take care, goodbye, and see ya.